very excited to be at RubyJam today. It's evening for you and morning for me. There's some basic information about me. I've been working on JRuby since 2005, really 2006 full-time. So this is 20 years of JRuby. Now running the company Hedius Enterprises, where we do support for JRuby users, help people do migrations, upgrades, investigate problems, and so on. So I hope I can come and visit Taiwan again in person very soon. All right, so first of all, about JRuby. So JRuby, of course, is Ruby on top of the JVM, the Java Virtual Machine. We focus on trying to make JRuby be a Ruby implementation first. We want it to be as easy for Ruby users to migrate to. All the same commands work. Ideally, it should be just like regular Ruby. But then, of course, being on the JVM, we get many benefits from that platform that I'll talk more about in a little bit. Ruby code should just work. So we recommend everybody just give JRuby a try. However you're installing Ruby, you can install JRuby the same way. And if something doesn't work, please let us know. So here we are on my system. I have OpenJDK version 26. Any of the Java versions, any of the JVMs that are available will install and work just fine with JRuby. And here I'm using Ruby install. You can just Ruby install JRuby. Here I'm installing specific version, JRuby 10.050, the most recent version. And there it's installed. Now we can run the commands that we're used to. We've got IRB. We're equivalent to Ruby version 3.4.5 in this release. We have our JRuby version 10.05. And now we can actually start calling JVM classes too. We've got all of Ruby available, but also everything that's on the JVM. So we call Java Lang runtime, we get that. We've got access to available processors. We can see what free memory is and so on. Very easy to call any Java class, any Java library directly from Ruby. So compatibility-wise, like I mentioned, JRuby 10 is Ruby 3.4 compatible. Pretty close to 100% passing on everything. The missing bits are things like fork and some weird process launching stuff that just isn't supported by the JVM. Pretty much all of the pure Ruby standard library, we use the exact same code as CRuby. And for most of the native extension parts of the library, we have JRuby versions that work just the same and pass all the same tests. We have Rails 8.x support just about ready for our database drivers, which use JVM database support. Just about ready to release. There's some people running directly from the master branch, the head branch, and they tell us that it works just fine. So when you have used JRuby for a while and you want to deploy it, we also support the Puma server. It works just fine. And if what you're comfortable with, we recommend sticking with it. We also have the ability to package JRuby apps as a single file. Using Warbler, you can turn it into WAR files, web application archives, to deploy on Java servers, Java app servers, or deploy applications as standalone jar file. You can just tell Java to run this, and it includes JRuby, all of your dependencies, your whole app in a single file, no native extensions, no build tools necessary to deploy it. It also can pre-compile all of your code internally to JRuby's format and basically obfuscate code. We have people that sell commercial software that is completely written in Ruby, but packaged up like this with JRuby. JRuby-Rack is the piece that connects Rack to any JVM servlet engine, JVM app server. And then, of course, you can call all the existing JVM libraries. So it's easy to embed JRuby into a larger app, into a big JVM application. So the advantages of the JVM. We are a first-class JVM language. Extensions for JRuby are written in Java, not insecure C code, and no build tools required on your production system. The JVM optimizes Ruby code just like it optimizes Java. It all inlines together. It performs extremely well. And we get the same benefits from the JVM's garbage collectors. They are concurrent. They're very efficient. You can have very low pause times or no pause times in the garbage collector. So we basically have made Ruby a first-class JVM language, so you don't have to write Java. You don't have to know anything about Java. You can just live within the Ruby world, but get the benefit of that platform. I mentioned the GCs. There's many different options for garbage collection on the JVM. Large heaps, small heaps, enormous heaps. You can have terabyte-size heaps if you need to. You can configure it to be faster allocating new objects or to have short pause times. And the standard OpenJDK comes with a bunch of different GC options for different types of applications. This is an example tool that's standard for OpenJDK called VisualVM. On the left side, there's some basic graphs about the CPU usage. I think I was running a little Rails app for this example. CPU usage, the amount of heap space that's used, how many classes and threads there are. On the right side is a plugin called VisualGC. This lets you actually watch the garbage collector work in real time, and you can see if things are leaking, see if memory is increasing over time. Ideally, you want to see that nice sort of sawtooth shape. Memory goes up, gets collected back down, and then you can monitor and see if you're losing memory. We also get the benefit of the JVM's performance. So we compile Ruby code down to JVM bytecode, and that JVM bytecode then is turned into native code by the JVM. So JRuby, in about 2008, we were the first Ruby to have a native JIT for Ruby code. So there's dozens of people that have worked on this for decades, really excellent JIT compilers, amazing design, and we get the benefit running Ruby on top of the JVM. So a quick example of this, recently in Ruby 3.5, actually 4.0, there was an optimization called the Opt.new instruction. The goal here was to make new object creation much faster. So if you look at Ruby 3.4 with YJIT, 10 million Object.new allocations per second, it's pretty good. But because constructing a new object called back out to sea, the YJIT had trouble optimizing it, couldn't do as good a job. So they added the Opt.new instruction, which increased that about 30%. So 30% faster as far as Object.new allocations per second. So this is great, and we're excited to see all of these improvements in YJIT and in the standard Ruby. But then, of course, we're doing the same optimization on the JVM, and the JVM is incredibly good at optimizing object allocations. It kind of changes the whole scale of things. So here we're talking hundreds of millions of objects being allocated per second because the JVM's garbage collector is very efficient, the JVM JIT is very efficient, and this translates to faster applications, better scaling for your Ruby code. And then, of course, the JVM is fully concurrent with full parallel threads. We have Ractors that are being improved steadily in regular Ruby, but they can be difficult to use. As anybody who's used Ractors probably has noticed, you need to write Ractor-friendly code. So it needs to be primarily immutable objects. There's a lot of overhead crossing that boundary. Yes, you can get your Ractors to run in parallel, but if you want them to coordinate, it's very expensive. It's also sharing a single heap and a single garbage collector, so you can overload the garbage collector very quickly with all of those Ractors. In JRuby, threads are already 100% parallel. Of course, using immutable objects is always a great strategy for thread safety, but we have very low overhead for threads using the same shared memory. There are libraries like Concurrent Ruby that provide threaded executors, thread-safe collections, all of which work excellent on JRuby and let you really get full parallelism out of a simple, single, normal Ruby application. So here's an example of a threaded version, just trying to parse JSON as fast as possible. So we pull JSON data off of the queue, we pass it into the JSON library to parse it, and try to do this as fast as possible across many threads. Now, if we run this with threads on JRuby, we only get a 0.1 increase. There's a little bit of parallelism that we get slightly better. JRuby with Ractors, still not a whole lot better. We're still contending for the same heap space. We're still bottlenecking on a lot of the same things in the Ruby runtime. If we run this with JRuby, though, of course, it's real threads. Those threads are all doing their own independent JSON parsing. You can get real parallelism. On this case, a 4-core system actually using all 4 cores and maximizing your usage. The final area of JVM I want to talk about is the tens of thousands of libraries out there for graphics, graphical user interfaces, all sorts of high-performance servers, document formats, and then, of course, a whole large growing library of artificial intelligence, AI, and LLM tooling as well. Really, it's one of the largest collections out there, and this is all easy to use to pull into your Ruby codes. We use a little bit of magic, Ruby magic, to make it look like regular Ruby. But once you get the library loaded in, you probably would never even know you're writing against the Java library. So this is an example of a blog post I did a while back using a library called JFreeChart. It's a very popular and classic library on the JVM for doing charts and graphs. Here is a little snippet of Ruby code. So we're pulling in a few of the classes from the JFreeChart library using the 3D chart data here. Notice I'm just using a normal file.read, a normal JSON load, and then I iterate over all of the elements in that JSON to populate the data set for this 3D graph that we're going to do. And there's a bit more code. You can go look at the post. But in the end, we get something like this. And this is with no customization. Easy to make some improvements on the color, make some formatting changes, but without installing any additional library, without any native code required, we can build charts like this very easily from Ruby code. So here's a few quotes from big JRuby users that we've got out there. Quantum Inventions is out of Singapore. They basically use JRuby to deploy little applications on customers' sites, on premises for customers. Little tools for data management and other tools. Logstash, a lot of folks I think know about Logstash. JRuby has powered Logstash for many years, and it was really the only choice. They needed a simple single process that they could deploy that would be fully multi-threaded and be able to use all of the Java ecosystem. So Logstash has been a JRuby user for a decade and a half now, I think. Poshmark is another large user. They do online sales, sort of like eBay, but also with new products and whatnot. Poshmark has been using JRuby to scale their application for over a decade, and they continue to be a very big user, an important user of ours. Substitute Alert is an application in the United States for managing substitute teachers. So this needs to run very parallel, be able to send out lots of notifications when a substitute teaching job is available. And we work very closely with Mohammed at Substitute Alert, and he's been very happy that we've been able to help his application. So JRuby Futures. We are just about to wrap up JRuby 10.1, hopefully get that out before RubyKaigi next week. We are doing a whole bunch of new optimization. We are caught back up on compatibility. So JRuby 10.1 will be Ruby 4.0 compatible. There's much less memory use. We've reduced the memory. We've had better JIT compilation, better integration with Java. And now we're starting to leverage a bunch of new JVM features. Project Lilliput shrinks all JVM objects, which makes JRuby applications much more compact in memory. We are looking at integrating native library support at the JVM level. Project Laden also allows us to pre-optimize, pre-JIT JRuby and Ruby code to start up quickly and warm up much faster. Basically, you keep upgrading your JVM and your JRuby code will just get faster for free. So there's a lot of fun stuff coming. So if all this is interesting to you and you're wondering where to start, of course, my company, we're happy to help people get going on JRuby. Hedius.com is where to go. Hedius Enterprises. We've been working on this runtime for 20 years, and we're very good at helping people migrate and get their applications upgraded. This is expert support for JRuby users. Everything from new development to migrating existing applications. We can help get bugs prioritized, get releases out. And this is not just a new venture of mine. This is how JRuby development is funded today. This keeps me working on the project and keeps me bringing all the opportunities of JRuby to the Ruby world. So check it out and let us know if there's anything we can help with. And that's all I have today. There's some more contact information for me. And I hope to see all of you in person someday soon. Thank you.
Thank you, Charles. There are some comments on Slido now, so I'll just read them to you. So first, someone says, let me recall that we used JRuby to run a small server in the company, so we could use Java libraries from Taiwan banks while still using like Ruby. Yeah.
Right. This is a perfect example. Yes. Who is was anybody in the room this question? You wave your hand. Maybe somebody online. Yes, this is a perfect example. JRuby can be deployed like any other Java application. And so when you go to big organizations, big enterprises, you can build Ruby and Rails applications and deploy them right into the regular Java application server stack. Makes it really easy to use Ruby in a whole new world where Ruby never could be deployed before.
Yeah, banks in Taiwan really like Java.
Sure, yes. So there you go. All of those companies that use Java, they could be running Ruby applications and you could be building tools for them.
Speaking of ecosystem, I think it's also good that we don't have to experience the C extension hell. Like, yeah, I personally have experienced that. And it's just really hard to debug for me as a Ruby developer. And as far as I know, I will not have that kind of experience very much in JVM if I use JRuby. Yeah.
Yeah.
So there's another comment, but I think you already answered it in your talk.
Right. Yeah, the impressive brands. I mean, obviously, Logstash is a big one that a lot of people are familiar with. There are a couple large Fortune 500 companies that we're still working on making that public, but they run JRuby as the core of some of their biggest applications. So there are many companies around the world, big enterprises, banks, financials, medical, all sorts of places that use JRuby. You probably have used JRuby in one way or another every day that you're out there, because there's a lot of users.
Any other questions? Oh, Alex.
Yes, JRuby. Using JRuby to script Java ORMs like Hibernate. Yes. So for something like Hibernate, you would still do the object model in Java, and for that you can probably generate much of that code. But once you have the Hibernate Java object model ready, you can just call that like a normal Ruby library. All the same APIs work, all the same Hibernate Java ORM objects would just be like Ruby objects in JRuby. So any of the Java database libraries, any of the ORMs, the servers, all of that, easy to use from Ruby code.
Hi, Charles. I actually had an impression that you are joining in person, but online works too, and hope you come visit this lovely country that is Taiwan. I wanted to ask you how this emergence of AI changes your personal approaches to work on JRuby, or any tools you are using outside of IDE to work on JRuby nowadays, or maybe any tips for us as developers?
Sure. So we have tried to use AI for parts of JRuby for small things, small bugs and improvements. We're able to get some benefit from it. We have some users that will use, I think some folks are using Copilot, some folks are using Claude to put together small patches. Usually those are pretty good. What we have found is JRuby is large enough and unusual that a lot of the AIs that are out there don't do a great job on large tasks. We had someone not familiar with JRuby try to use Copilot to fix a memory leak that they found in JRuby. And the patch from Copilot actually introduced more memory leaks. So we've been very cautious about this. My recommendation is keep the tasks small. Try to use smaller tasks. Make sure you are reviewing the code that comes out of this and understanding what these changes are. Try to help the AI keep this code clean, because bad code is just as bad for AI in the long term as it is for humans. And just don't try to do too big of tasks at once. You can't make the current tools build an entire application and expect it to run well and be maintainable.
Yeah.
Thank you.
Yeah, Alex says thank you. So I think we have to move to the next issue. And thank you for joining us.
Sure. Thanks very much. I'll stay online for a little while too. Thank you.